if we have half of a pizza, and I wanted to get half of that half, how much do I have? A whole? What I'm asking is, what is half of a half? So what is half of a pizza? It's a quarter, yeah. It's a quarter of a pizza. Yep. So if I half, this is half a pizza, this is half a pizza, and if I half that, I only have a quarter of a pizza. Make sense? Okay. So half of a half is 1/4. What's a quarter of a half? Well, that's a half again. If I split this up into quarters, that's 1/4 of the half, isn't it? 1/8. That's 1/8, yeah. 1/4 of a half is 1/8. Okay. Is there a quicker way of doing this without drawing? Okay, so if I say 2 groups of 4, how do I work out how many that is? I do 2 times 4, don't I? So of in maths is multiplication. Of. So 1/4 times a half is 1/8. We drew it. And you may notice that, yes, if I just multiply the denominators, I get 8. And if I multiply the numerators, I get 1. So multiplying fractions is actually quite straightforward. If I have something like 3/4 multiplied by 2/3, I can multiply the numerators, 3 times 2 to give 6, and multiply the denominators, 4 times 3 to get 12. And then, yes, I can simplify that. We can maybe see that they're both divisible by 6. 6 fits into 6 once, 12 fits into 6 twice, and I got 1/2. So to multiply fractions, quite straightforward. You just multiply the numerators and multiply the denominators. Now sometimes you can do a process of simplifying before you multiply, so pre-simplification. I want you to look at this one I just did. 3/4 multiplied by 2/3. Really, this is just, if I just put it over here, multiplied by 2/3. I could write this as, 3 multiplied by 2 in the top and 4 multiplied by 3 in the bottom, couldn't I? I'm doing that, really. Just multiplying the top 2 numbers. And when I multiply, it doesn't really matter what order I put it in. So the 2 and the 3 could switch orders, because I still get 6. It's a commutative property of multiplication. Nico? So if I multiply something by 3 and divide it by 3, I'm not really going to change it, am I? So because that's just 1, isn't it? 3 over 3 is just 1. And 2 over 4 is a half. So I could have got 1/2 by just simplifying before I multiplied 1 times 1 and 2 times 1. 3 fits into that, 3 fits into that once, 2 fits into that once, 2 fits into that twice, and that gives the same answer. Now, if you don't really like that, that's okay. You can do this the longer way and just multiply the numbers and simplify afterwards, no problem. The crucial thing is that remember for multiplication, if I have a question like this, 2 times 7 multiplied by 1/3, I now could do it quite quickly. 2 times 1 in the numerator gives 2, and 7 times 3 gives 21, and that one I cannot simplify, and that is it. So multiply numerator by numerator, denominator by denominator. That is multiplication of fractions. Pretty straightforward, yeah? Right. And then we move on to dividing fractions. How do we divide fractions? So what's a half divided by a quarter? What is a half divided by a quarter? Another way of thinking about this question is, how many times does a quarter fit into a half? Okay. Let's think of a whole number example here. 8 divided by 2 is how many 2's fit into 8? What's the answer? 4. Okay? We can always check our answer by saying, oh, 2 times 4 must give 8, working the opposite way in division. So, what's our answer here? Think about that again. A quarter, how many quarters fit in a half?
1/2.
1/2. Well, the usual two options maybe is 2 or 1/2. Well, if we put in 1/2 here, we've just figured out that multiplication of fractions is multiply denominators. So 2 times 4 should give 8, and this is not working out for me. 1 times 1 does give 1, but 2 times 4 does not. So it's not going to be this, because it has to work the other way. Multiplication always works in opposition with division. Yeah.
Maybe 1/8.
That wouldn't work either. If I have 1/8 here, 8 times 4 gives 32, not 2. It's not working. Because remember, it has to work backwards. 4 times 2 gives 8. Yeah?
Maybe 0.5.
Well, let's draw a visual. If I have half a pizza, how many quarter pizzas fit in that? In the half. How many quarter pizzas there? 1, 2. So I know that 2 quarters fit in 1/2. So a quarter divided by a half is 2. 2 quarters fit in 1/2. How do I get that every time? So if I have a more difficult question, such as 3/7 divided by 2/3, how do I do that one? Yeah.
It's like same as you have to times 7 by 3. You have to make the denominator same.
No, denominator. Well, you could make the denominator the same and then see how many times it fits in. Yeah, that's one way of doing it. Yeah. Might be a little bit slower. I have another method. Anyone know of another method? Yeah.
See how many times the thing can go to the 7, which is 2 times. And then
It's a bit tricky then, yeah.
add 1 to the numerator.
Maybe. Let's think of another whole number example. What's 8 divided by a half? Not multiplied by a half, which is what you're giving me the answer to. How many times does a half fit into 8? 16 times, yeah? 16 times. In a way, you can think about multiplying the 8 by what? By 2, yeah. So if I multiply by the opposite fraction, I get the correct answer. If I multiply by what's called the reciprocal, which is the opposite number, I get the same answer. Did that work up here? 1/2 multiplied by 4/1. Now if I multiply this, 1 times 4 gives 4, 2 times 1 gives 2. Is that 2?
Yeah.
4/2 is 2, yes. It simplifies down to 2. So instead of dividing, which can be a bit tricky to figure out how many fit into it, we can do the opposite operation and multiply. Because remember, division and multiplication are opposite operations. So if I multiply by the opposite number, I actually end up dividing. So let's formalize that. Multiplying by the opposite number instead of dividing. I'm going to do this question over here. 3/7 divided by 3/7, yeah, you're on the right track, yeah. 3/7 divided by 2/3. And my method is I'm going to remember fried chicken. I remember KCF. Well, spelled wrong. Kentucky chicken fried. This stands for keep the first fraction the same, change the sign to multiply, and I'll use this arrow. And then flip the second fraction. Flip is the typical, the mathematical term is reciprocal. Reciprocal is when we flip a fraction. So what I'm going to do is I'm going to keep the first fraction the same, 3/7, I'm going to change the sign to multiply. That's what the change means. And I'm going to flip the second fraction. Instead of 2 over 3, I'm going to write 3 over 2. And then it becomes a multiplication question, which we just figured out was pretty straightforward. Just go straight lines. 3 times 3 is 9. 7 times 2 is 14. And that is the answer. That's how we do it. We take fried chicken, keep the first fraction the same. Change the second fraction, or change the sign to multiply and flip the second fraction. Let's look at another example. Three fifths divided by 2 11ths. So many times does 2 11ths fit into 3 fifths? Ooh. It's easy. We just keep the first fraction, change the sign to multiply, and flip the second fraction, and then we multiply. 33 over 10, or 3 3/10. Done. So I'm just multiplying for dividing. Keep, change, flip. Make sure you've written that somewhere and an example of what to do. Going to do one more example. This time I'm going to use a mixed number. I'm going to stick with division. Go do a mixed number. Example 3. Two and 1/5 divided by 3 and 2/3. LZ knows what to do. Do my third example over here. All right, I have a problem here. I've got mixed numbers. Can I do this method with mixed numbers? No, I got to use improper. Nico's going to tell me what the two impropers are.
You go 11 over 5.
Very good. 11 over 5. 5 times 2, added to the top. 10
11 over 3.
divided by 11 over 3. So now I can use my keep, change, flip. Keep the first one is still 11 over 5. Change to multiply. Flip the second one, 3 over 11. Now this one you can do 33 over 55, or you can do a little pre-simplification. 11 fits into that once. 11 fits into that once. Makes it a little bit easier rather than dividing by 11 afterwards. 1 times 3 is 3. 5 times 1 is 5. Or you get 33 over 55 and then divide by 11. But 3 fifths is my answer here.